Hello and welcome to the up-degree course on data structures with C++. We are discussing the stack data structure. In this class, we will look at an application of stack in converting infix expressions to postfix expressions. So basically, what is an infix expression? An infix expression is an expression in which the operator is placed between the operands. For example, a plus b or x minus y multiplied by z or p divided by q to the power r, etc. So basically, this is an expression which we use in our algebraic operations, and we are very much familiar with these kind of expressions. So this is easy to read for humans, and we know that the expression x minus y star z will happen in this order, that the multiplication would occur before the subtraction. And this is because each operator in an infix expression has a precedence level. Operators of higher precedence are used before operators of lower precedence. For example, if you look at the expression x minus y star z, in which we know that the multiplication has a higher precedence than subtraction. So multiplication would happen before subtraction. The only thing that can change that order is the presence of parentheses. For example, if you write the expression as x minus y within brackets and then multiplied by z, then of course the subtraction will happen before multiplication because x minus y is given within parentheses. Now, in case of prefix or postfix expressions, for example, in case of prefix, the operator is placed before operands. For example, plus ab, minus x star yz, etc. And in case of postfix expression, the operator is placed after operands. For example, ab plus, xyz star minus, etc. Now, prefix and postfix expressions don't need parentheses. For example, if you look at the expression x minus y within parentheses multiplied by z in infix, which can be expressed in prefix as star minus xyz and in postfix as xy minus z star. So the order of operations within prefix and postfix expressions is completely determined by the position of the operator and nothing else. And this makes prefix or postfix expressions easier to parse by a machine. An infix expression can be converted to its equivalent prefix or postfix expression using a stack. So basically in this class, we are going to look at the conversion of infix expressions to postfix expressions, but a similar algorithm exists to convert infix expressions to prefix expressions as well. And I will leave it to the interested user to try to convert an infix expression to a prefix expression after you have studied the method to convert infix expressions to postfix expressions. So with that, let us begin to convert an infix expression to a postfix expression. Okay, so I'll present you the algorithm to convert infix to postfix, but before that, let's look at an example. And here is an infix expression. Okay, bracket a plus b minus c star d divided by e to the power f. This symbol is to the power. Okay, so let's look at an algorithm to convert infix to postfix. So firstly, we will have to scan the symbols in the infix expression one at a time. Okay, so we are going to read from the leftmost symbol of the infix expression and read one symbol at a time and perform some operations and go on till we reach the last symbol of the infix expression. Okay, and we are also going to use a stack to keep some things in between, and eventually we are going to build a postfix expression which is equivalent to the given infix expression. Okay, let's begin. So if you're going to start from left to right, the first symbol that we scan will be a left parenthesis. So the rule says if the input character is left parenthesis, then push it to stack. So the symbol scanned is left parenthesis and we push it to the stack. Okay, the next symbol is a, which is an operand. So the rule says if the input character is an operand, append it to postfix. So we get the symbol a and we append it to postfix. The stack still has a left parenthesis. The next symbol would be plus, which is an operator. So if it is an operator, then we have to see what is the stack. If the stack is empty or the top of the stack has a left parenthesis, then we have to push the operator to the stack. So in this case, the stack top has a left parenthesis. So we are going to push the operator plus to the stack, and the postfix expression remains the same. All right. Next symbol to encounter would be B, which is an operand, and as our rule says, if it is an operand, we have to add it to postfix. So once we have scanned the symbol B, we are going to append it to the postfix. Okay. So the next symbol is right parenthesis. So in case the next symbol is a right parenthesis, our rule says pop and append the postfix until the top is left parenthesis. So you see, we have to pop from the stack, so we'll get plus out of the stack and we are going to append it to the postfix, and then we get a left parenthesis, and once we get the left parenthesis, we have to pop the left parenthesis and discard it. Okay, so in this case, we are going to get the right parenthesis as the next symbol. We are going to pop the plus operator from the stack and we are going to append it to postfix. Then we will pop the left parenthesis also, but discard it, don't append it to the postfix. So that makes the stack empty. Okay, what is the next symbol? The next symbol is minus, and in case we get an operator, our rule says if the stack is empty or the top of the stack has left parenthesis, then push it to the stack. In our case, now the stack is empty, so when we get a minus, we are going to push it into the stack. The next symbol is C, which is an operand. In case of an operand, we know that we have to append it to the postfix. The next symbol is multiplication. Now in this case, we are getting an operator and the top of the stack does not have a left parenthesis or the stack is not empty. In that case, if the top of the stack has another operator, we have to check the precedence value of the operator that we are scanning right now, and if it is greater than the precedence value of the operator on top, then we have to push it into the stack. Now you see, we are getting a multiplication symbol star. The precedence of multiplication is greater than the precedence of the operator which is on the top of the stack. So in such case, we have to push this operator into the stack. Okay. Next symbol is D. So it is an operand and we are going to append it to the postfix. The next symbol is division. Okay. Now, in case the precedence of the operator scanned is lower than or equal to the stack top, then we have to pop from the stack and append to postfix, while precedence of the stack top is more than or equal to the precedence value of the input character. Now look at this. We are getting a an operator which is division. Now what is the precedence of the operator on the stack top? Multiplication. Division and multiplication has equal precedence. So what we have to do is pop out the multiplication and append to postfix, and then again go to the next operator, minus, but minus has a lower precedence than division. So we don't pop out minus, we will push division onto the stack. So basically when we get a division symbol, what will happen is star will be popped out of the stack and will be appended to the postfix, and then we will keep minus and push division onto the top of the stack. Okay, next symbol is E, which is an operand, and we are going to append it to the postfix. Okay, next symbol is exponent operator. So in case we get an exponent operator, then we have to look at rule number 3b. The precedence value of the operator is greater than the precedence value of the operator which is on the top of the stack. Basically, the precedence value of exponent is more than the precedence value of division, so we are going to push it onto the stack. Then we get F, which is an operand, and we are going to append it to the postfix expression. Finally, we have come to the end of the expression, but the stack is still not empty. It has 3 operators, so we have to pop the remaining elements from the stack and print them. Printing them means appending them to the postfix expression. So basically our postfix expression then looks like AB plus CD star EF, and then followed by the remaining operators on the stack, which is exponent, division and minus. So this is the equivalent postfix expression for the given infix expression. Now let us write C++ code to implement this conversion. So for this we need to add methods to firstly find out the topmost element of the stack. If you remember the algorithm, at every step almost we are checking what is the topmost element of the stack. So we will add a method called pip into our stack class, which basically checks if the top is equal to 0. That means if the stack is empty, then it throws an exception. Otherwise, it simply returns the data of the topmost element. Okay, another method that we need to add is to check whether if the given symbol is an operator or not. And in this method, we are simply checking whether the symbol is plus, minus, star, division or exponent. In this case, the method will return true, otherwise the method returns false. The next method that we want to add is to return the precedence of a given operator, and in this case, if the operator is plus or minus, we are returning the precedence value of 1. In case of multiplication division, we return the precedence value of 2. In case of exponent, we return the precedence value of 3. For any other operator, we return the precedence value of 0. So basically what we are saying is exponent is the operator with the highest precedence, followed by division, multiplication, and then followed by plus and minus. Okay, so with this, let's look at the method to convert from infix to postfix. All right, so I have kept the algorithm side by side with the code so that it is easier for us to understand the implementation. Now, if you look at this method, this method accepts a string in infix notation and it returns a string in postfix notation. All right, and we have restricted the method to accept every operand as one character only. If the operand is of more than one characters, then this method doesn't work in the present form. But okay, we can make simple changes to make it work. So in the first two lines, we are just printing some headings for our algorithm. So we are just printing the word symbol followed by 2 tab spaces, then stack, and then followed by 3 tab spaces and postfix, and then we are basically printing a line after that so that this becomes a heading. Okay, when we look at the output, it will be more clear to you. Then we are creating a string called postfix. This will be the output. Okay, we are going to return this string after we build a postfix notation, and of course we need a stack, so we have created a stack of characters. Now in this for loop, we are going to scan the infix expression from left to right, one character at a time. Okay, and the symbol which we are going to scan is going to be judged based on the type of the symbol on the operation that we perform. Now if you remember, if the input symbol is left parenthesis, then our algorithm says push it to the stack. So if you look at these lines, here with the symbol is left parenthesis, so we are going to push into the stack. Okay, if the symbol is right parenthesis, rule number 4 says pop and append to postfix until top is left parenthesis, and then pop the left parenthesis, discard it. So if you look at this part of the code, here we are checking if the symbol is right parenthesis, and then we are going to see if the top of the stack is a left parenthesis or not. Until the top of the stack becomes a left parenthesis, we are going to pop from the stack and append to the postfix. And finally, when the top of the stack becomes left parenthesis, we are going to pop that out of the stack and simply discard it. All right, so that implements rule number 4. Now, if the top of if the symbol scanned is an operator, then we have 3 rules: 3a, 3b, and 3c. Now in 3a, it says if the stack is empty or top of the stack has left parenthesis, then push it to the stack. So you see here in the if condition, we are checking if the stack is empty or the top of the stack is the left parenthesis, then we will push it into the stack. Okay, rule number 3b says if the precedence value is greater than the precedence value of the stack top, then push it to the stack. So we are checking if the precedence value of the symbol is greater than the precedence of the stack top, then we are going to push it to the stack. And according to rule 3c, if the precedence value is lower than or equal to the stack top, then pop from the stack and append to postfix, while precedence of stack top is more than or equal to the precedence value of the input symbol. So basically this is implemented here. If the precedence value of the symbol is less than or equal to the precedence value of the stack top, then we are going to pop it from the stack top and append it to the postfix expression. We will keep doing it till the precedence value of the symbol becomes greater than the precedence value of the stack top. Okay, and then we are going to push our symbol to the stack. All right, so if none of these conditions are true, then the symbol scan must be an operand, and in case it is an operand, rule 2 says we have to append it to postfix. So we are going to append it to postfix. And finally we have printed the symbol, the stack and the postfix, so that we can see at every step what has happened. Okay, so once this for loop is over, we have completed scanning the infix expression. If then the stack is not empty, we have to pop from stack till it becomes empty and append it to the postfix expressions. Okay, and finally we return the postfix string that we have just created. Alright, this is a method to convert from infix to postfix, and then this is the main. In the main, we are simply taking an infix expression and converting it to postfix and printing it. So let's see our code and run it and see what is the output. So if you look at the output, we have the infix expression parenthesis a plus b minus c star d divided by e to the power f, and the corresponding postfix expression as we get is ab plus cd star ef exponent division and minus, and at every step of the algorithm what has happened in the stack and what is the equivalent postfix expression is given on the right hand side. Okay, so I hope you have understood how an infix expression can be converted to its equivalent postfix expression using a stack. In the next class we will look at another application of stack in evaluating postfix expressions. Thank you.